Hey, what's going on, guys? Welcome to my Python crash course for beginners. Now, I did a crash course about a year ago, and we used the Eclipse IDE. And what I've always hated about that video is the unnecessary amount of time that I took just to set up Eclipse. It was like 12 minutes or something like that. And I wouldn't even suggest using Eclipse anymore. We're going to be using VS Code, which is what I use for virtually everything I do. I also missed some things, and it just could have been a better video. So we're actually going to just jump right into it. And what I'm doing is using the Python sandbox, which is actually from my Django course on Udemy. I'll put a link in the description if you're interested in that. And if you look in here, and the link to this is in the description to this repository. So we just have a bunch of starter files for certain things we'll be looking at, like strings, functions, classes, and they basically have nothing in them but maybe some comments, and we're going to add to these as we move along. So you might want to download the sandbox and go ahead and open it up in VS Code or whatever text editor or IDE that you're using. So as you can see, I already have all the files open here, and we're going to be starting with variables.py. So you can go ahead and open that. Now, obviously, you need to have Python installed so that your system can interpret the Python code. So you need to have Python 3, which you can get from python.org. Just go to downloads. I'm on a Mac, so I would just click here. If you're on Windows, you can download the installer. So you just want to get that installed and then open up a terminal. VS Code has an integrated terminal that I'll be using. And if you say Python -- version on a Mac, you're probably going to see Python 2.7, which is not what we want to use. Once you install Python 3, if you say Python 3 -- version, you'll see either 3.7 or whether it's a later version or whatever, as long as it's version 3. If you're on Windows, you'll probably see version 3 with just Python. Okay, so whatever is version 3, that's what you want to run your files with. So let's clear this up and we'll get started. So this variables.py, we're going to go over a couple things. We're going to go over how to define variables, some of the rules, and also data types, okay? Because just like with any language, there's a bunch of different data types. We're only going to look at the more common ones. There's others that aren't used very much. I'm not going to get into. This is a crash course. But basically, a variable is a container for a value, which can be various types. And if you know any other language, I'm sure a lot of you guys know JavaScript. If you've been following my channel, you know what a variable is. Okay, so before we talk about variables, though, I just want to quickly look at how to comment in a Python file. And by the way, your Python file should end with a .py extension. So a number sign or a hashtag, whatever you want to call this is how you can do just a regular comment, just a single line comment. These triple quotes, whether single or double, these are called docstrings, and they're often used to define functions. So you'll see these a lot in function declarations, but they can also be used for multi-line comments, as you can see here. So let's go over some of the variable rules, or the naming conventions. So they're case sensitive. If you create a variable called name all lowercase and name all uppercase, these are going to be different variables. Okay, they must start with a letter or an underscore. They can have numbers, but they cannot start with a number, and that's a very common rule for variables in many different languages. All right, so let's start off by creating some variables. So I'm going to create one called x, and I'm going to set it to 1. And now in Python, there's no semicolons. So if you're coming from JavaScript, even though you don't need semicolons in JavaScript, most people do use them. If you're coming from PHP or Java or any language like that, you're probably used to semicolons. So you might find yourself screwing up a little here and there and putting in a semicolon. I know I still do it. But yeah, no semicolons. Also, when we declare a variable, we don't have to do like var or anything like that. There's no special symbol like PHP. It's just simply the whatever you want as the variable. We also don't have to do like int or anything like that. Now, this is going to be casted as an int by default. So I'm just going to put the variable type here of int. And I'm going to set another variable of y, and I'm going to set that to 2.5. So this is actually a float, okay, or a floating point number. Next one is going to be name, and I'm going to put some quotes here, and we'll say John. And this is actually a string, or an str is the official type. just put these. I want to make this nice and neat just so you guys can have this as a reference later on. And I will have the finished version in the GitHub as well. And by the way, strings can have single quotes or double quotes, but I prefer single. And let's do is cool, and we'll set that equal to true. And this is a Boolean or a bool. Okay, now it's important to know that with Booleans, you want to have a capital T for true or a capital F for false. If I do that, it's going to be looked at as a variable called true, which doesn't exist. Okay, so those are the main types that you'll be dealing with. So there's an easier way. If we want to declare all these variables, we can actually do a multiple assignment. So let's go ahead and say multiple assignment. And again, I'm going to put a lot of comments in this code in this sandbox just so you guys have it as a reference. So let's say we want to do exactly what we just did above. We could say x, y, name, and is cool. And we could set that to a set of parentheses, and then we can put the values. So 1 and 2.5, a string of John, and a Boolean of true. So this line here does exactly what we did up here, only it's more compact. Okay, so let's go ahead and output something. So in Python we have a function called print that we can use. Now if you've ever used Python 2, you might see something like print hello. In Python 3 you want to make sure that you use parentheses. Okay, so we want to go like that. So if I run this file by saying Python 3 and the name of the file, which is variables.py, we get hello. Okay, if I want to output one of these variables like x, we'll go ahead and run that. We get 1. We can also output multiple things, so we'll do x, y, name is cool, and we'll run that, and you can see it will output all of that stuff. All right, and of course we can do most of the stuff that you can do in any other language, like for instance basic math. I could create a variable called a and set it to x plus y, and if we wanted to add a on the end of this print right here and run that, you'll see we get 3.5. Now we can also check the type. So let's say we wanted to check the type of x. We would do let's do a print, and in here we're going to use the type function. So we're going to say type and x, and let's see what that gives us. So it gives us this class int. Okay, so the type is going to be in here. Now there may be cases where you want to cast a different type to a value. Like let's say we want to make x, which is an int of 1. Let's say we want to make that a string of 1. So we can do casting. So I'm going to set x equal to, and then I'm going to use str. Okay, so we can use the type and then pass in whatever we want to turn into a string, which is x itself. And then I'll go ahead and run this, and now you can see that we get class str. If we want to change, let's say y, which is a float, into an int, we could say y equals int, and we'll pass in y, and let's print out y, and let's also, or the type of y, let's also print out y itself. Okay, so what we have now is int, y is now an int, and then we just get 2. Okay, so it went from 2.5 to 2 because an int is a whole number, whether negative or positive. Let's say we wanted to change y back to a float. Okay, so y is now an int of 2, so I'll create a new variable called z, and let's say float, and pass in y, and let's see what we get for the value of z as well as the type of z. And we get a class of float, and the value is 2.0. Okay, it's not going to go back to 2.5 because when we change it to an int, it was then turned to 2, and then we turned it back to a float, so it's going to be 2.0. Okay, so hopefully that makes sense. So we're going to move on. I don't want this to be too long. I want to keep it under 90 minutes. So we're going to move on to strings. Okay, so let's open up strings.py. And what I really want to go over is like inserting variables into strings. formatting them, and I want to look at some of the string methods and how we call those. Okay, all strings have methods attached to them, and we're going to look at some of those. So let's set a variable up here, a couple variables. One of name, we'll say Brad, and let's do age, which will be an int of 37. Okay, now to concatenate, which means basically to insert a variable into a string, we do that pretty much the same way that we would in JavaScript. So we could say like, hello, my name is space, and then we'll put a plus sign just like we would in JavaScript. And then if we run this with Python 3 strings.py, we get hello, my name is Brad. Now, let's say we want to put the age in there as well. So we would concatenate back to a string, and I am space, and then we'll put a plus sign in the age variable. And let's see what happens when we run that. So we get an error because we can only concatenate string, or str, and age is an int. So what we would do in this situation, if we really wanted to do this, is we would cast this to a string, just like I showed you in the last file. So we just wrap that in str and run it, and now it works. Now there's better ways to do this, to insert variables into strings. So we can do string formatting, and one way is to do positional arguments. So let's say arguments by position, and we're going to say print, and I'm going to put these curly braces in here. Okay, actually, you know what we'll do, let's just do my name is, and then I'm going to put curly braces and then name, and I am age. Okay, and then what we want to do is call the format method. So we do dot format, and then we can set name equal to name, which is this variable up here. Okay, and then we're going to set age equal to the age variable. So these are just basically placeholders. So whatever is in this right here should show up here when we run this. So I'm going to comment this one out and then run the file. And we get the same thing. My name is Brad and I am 37. And notice we didn't have to do any string format casting or anything like that. Now, this is one way to do it. There's another way, and that's using f strings. Okay, now f strings they're only available in Python 3.6 and after. Okay, so if you're using an earlier version, you shouldn't be able to use f strings, but they're pretty convenient. So basically what we can do is just put an f right here, and then put our quotes and say hello, my name is name, and I am age. Now that's all we need, because what's going on is this is an actual variable that's up here. So we're directly putting the variable into the f string, name and age. So if we go ahead, comment that out, and run this, we get hello, my name is Brad and I am 37. All right, so pretty easy. And this is very similar to JavaScript template literals, only instead of using backticks, we just put an F right here in front, and we don't use the money sign like that. Okay, I'm going to be making a lot of references to JavaScript because I know, that's mostly what I do on my channel, so I know a lot of you guys are JavaScript developers. All right, so let's move on here. I'm going to comment that out, and I just want to look at some string methods and how we do that. So let's set a variable of s, and I'm just going to set it to hello world, all lowercase, and let's say we want to capitalize string. So we can actually use a method called capitalize. So I'm going to do a print, and then all we have to do is take that string and then dot whatever the method is, in this case capitalize. Okay, make sure we put parentheses, okay, because it's a method, which is basically a function. So let's go ahead and save that, and we'll run it, and we get hello world. And notice that the first letter is capitalized. That's what it's going to do. Now I have some other methods here that I want to show you, but I'm not going to take the time to type them all out because they're basically used in the same way. It's just dot and then the method. So I'm just going to paste them in and go over them real quick. So we have upper, which is going to make all uppercase, make all your characters uppercase. We also have lower. We have swap case, which will swap the cases. This len is actually a function that can be used on strings, lists, basically any data type, and it's going to get the length. So in this case, it would get the amount of characters in the string. We also have a replace method. So if we wanted to take the word world and replace it with everyone, if we were to print this out, it would say hello everyone. Count, so if we want to have a substring like just H, we could count the number of H's inside the string. Starts with is going to return a true or false value based on how it starts. So this would return true because our string does start with hello. Ends with is the same thing, only it's going the other way. It's ends with. This would return true because our string does end with D. Split is going to take our string and turn it into a list, which is basically an array, and it'll have all the words in the list. Okay, find is going to find the position of a character. So in this case, it's going to look for the first R. It's going to give you the number, basically the position number. Is alphanumeric, alphabetic, and numeric. These are all going to return either true or false based on if all the values are either alphanumeric, alphabetic, or numeric. Okay, so let's go ahead and run this. And it's just going to log all of the prints that we have here. So basically this list right here is from the split. So it splits hello world into a list. Find is going to look for the position of the first R, which as you can see is 8. All of these, the alphanumeric, alphabetic, and numeric, these will all be false. And the reason for that is because of the space. If I were to get rid of that space, it's now alpha and alphanumeric. So we should get true for those two. So if we run that again, you'll see we have true for both alphanumeric and alpha. Of course, it's going to be false for numeric. All right, so yeah, I mean, there's other methods as well. I just wanted to give you some examples of some of the string methods. So let's go ahead and clear this up and let's move on. So we're now going to talk about lists, which are very, very important in Python. They're basically like arrays. So if you've dealt with JavaScript or PHP and many other languages, it's similar to an array. Okay, so let's first just create a list. And in the definition is a collection which is ordered and changeable. They also allow duplicate members. Okay, there's other data types that, for instance, are unordered and don't allow duplicate members, and we'll get into some of those in a little bit. But let's go ahead and create a list. So I'm going to say numbers, variable called numbers, and we'll set it to some brackets, and we'll just put a bunch of numbers in here. Okay, so that's one way to do it. We can also use a constructor. So I could say, let's do numbers 2, and we'll set that to the list constructor. And this is actually going to take in another set of parentheses, and then we can put our values in like that. Okay, so this is going to, both of these are going to create the exact same thing, a list with 1 through 5. So if I go down here and I go ahead and print numbers and numbers 2, and we run this file with python 3 list.py, you'll see that they're both the same, really. But this, I don't really like doing it this way. I don't really like using constructors. It's just like in JavaScript when you can say like new array and then put your array in, which I don't use either. So this is the more common way to create lists. All right, now I'm actually going to create another list called fruits, and this is the one we're going to work with. So this is just going to be an array of strings like apples, oranges, we'll do grapes, and pears. All right, so we have a list of strings. Now I want to go over some of the stuff that we can do here, such as get a single value from a list. So to get a value, let's do a print, and let's pass in the name of the list, which is fruits, and then we just want the index of whatever it is we want. Let's say we want oranges. We would use 1 for that, and the reason we use 1 is because lists are 0 base, okay? Just like pretty much any array in any language, it's going to be 0, 1, 2, and so on. So if I go ahead and run this, we get oranges. Now let's say we wanted to get the length of a list. So for that, we use the same len function that we use for a string. We just do len and then pass in fruits. Okay, so if I go ahead and run that, we get 4, because there's four items or values in this list. Let's say we want to add to it, or I should say append. We want to add to the end of the list. So we'll say append to list, and we can do that by just saying fruits dot append, and then whatever we want. Let's say mangoes, and down here we'll just go ahead and print fruits, and let's run this. Oops. And it's just gonna go ahead and add mangoes to our list and then print it out. All right, at the same time we can remove stuff, so let's say remove, and we'll say fruits dot remove, and then we can simply put the value in. Let's say we want to remove grapes. Okay, so if I save this and we go ahead and run it, notice that grapes is now gone. If we want to insert it into a specific position, not just append it, we can use insert. Okay, we'll say insert into position. So let's say fruits dot insert, and we want to pass in where we want to insert it, which is going to be position 2, and then the item we want to insert, which is strawberries. All right, so let's save that. And let's run it. Now you can see strawberries is now in position 2, 0, 1, 2. Now we can also remove from certain positions. So up here we use the remove method and we pass in the value. We can also remove it by the position by using the pop method. Let's say remove with pop. So we'll say fruits dot pop. And let's take strawberries out, which is in position 2. Okay, so if we run that, now you can see strawberries is gone. We can also reverse the list by saying fruits dot reverse. If we run that, now you can see that mangoes is first and apples is last. We can also sort, okay, if we want to sort alphabetically. We can say fruits dot sort, and if we run that, you'll see it's now in alphabetical order. You can also reverse sort by same thing, just calling sort, but passing in reverse equals the Boolean of true. And now if we do that, you can see it's sorted in the opposite direction. All right, so there's other stuff, there's other methods and stuff, but these are some of the really popular ones. Oh, if you wanted to change a value, you could do that as well. So let's actually, let's say fruits, and we'll say the first value, we want to change that to, I don't know, blueberries. Okay, so if I run that, you'll see, well, I mean, we're doing a reverse sort, so it's at the end, but it replaced apples, which was in the 0 position, with blueberries. Okay, so that's lists. Let's move on now to tuples and sets. Okay, so we want to go to tuples underscore sets.py. So a tuple is a collection which is ordered and unchangeable. Okay, and it does allow duplicate members. The important thing here is unchangeable. Okay, so let me give you some examples. I'm going to clear this up down here, and let's create a tuple. So we'll call this fruits, just like we did with the array. And to create a tuple, you want to use parentheses. Okay, we'll say apples, oranges and grapes. Now you can also use a constructor just like you can with lists in just about any other data type. So I could say equals tuple, pass in another set of curly braces, apples, oranges, and grapes. All right. And if I want to print fruits and fruits 2, and we want to run Python 3 tuples underscore sets.py, and there we go. So they're both the same thing. And I don't really use the constructor. So one thing to remember with tuples is if you only have one value, you want to leave a trailing comma. Okay, so if I say fruits 2 equals, and I go just apples like that. And what I'm going to do is I'm going to print out fruits 2, and I'm also going to print the type. Okay, so I'm going to say type fruits 2. And let's see what that gives us. So it gives us apples, no parentheses around it, and it says class string. Okay, so if you don't have the trailing comma, it's going to look at it as a string. If I put a trailing comma like that, even though it looks a little weird, if I run it, now you can see it's clearly a tuple, and it has a class of tuple. Okay, so just remember that. Let's say single value needs a trailing comma. All right, so to get a value from a tuple, it's just like you would with a list. So we could say print, let's say fruits 1, get rid of this. Okay, and we'll run it, and we get oranges because oranges is in the 1 position. Now, I showed you with a list, actually let me just put a comment here. I showed you that with a list we could say like fruits, grab one of the indexes and change it to, let's say, pears. But with tuples, you can't change the value. Okay, just right up here it says unchangeable. So let's see what happens when we run this. We get this type error, and it says tuple object does not support item assignment. Okay, tuples cannot be changed. Let's see what else. If we want to delete a tuple or anything really, we can use the del method. So we can say del. Let's do fruits 2. And then if we were to print fruits 2, let's see what happens. You'll see it says right here. Wait, actually it's still giving us the error from this, so I'm going to comment that out and run it, and it says fruits 2 is not defined. Okay, we did define it up here, but we deleted it completely, so now it's no longer defined. All right, we can also use len with tuples. So let's get the length of fruits. And we'll go ahead and run that, and we get 3. Okay, so fruits has 3 items in it. All right, so let's move on to sets. So I'm going to clear this out. Now, a set is a collection which is unordered. Okay, so it's unordered and it's unindexed. There's no duplicate members. Okay, so I'll show you exactly what that means. But to create a set, let's use fruits. Shoot, we already used fruits up here. We'll do fruits set. And a set is created with curly braces. And I mean, you kind of have to decide when you're programming. You have to decide what the best data structure is to use. Should you use a list? Should you use a set, tuple? I mean, every situation is different, and some work in certain situations and some don't. I mean, if you don't want to have duplicate members, then a set might be what you're looking for. But I'm not going to get into all of that stuff. This is just about syntax and learning the basics. So a lot of times you'll want to check if something is in a set, and there's a lot of different ways to do this, but we can just say apples in fruit set, and that's going to return either a true or a false. So if we run that, you'll see it returns true because apples is in the fruit set. We can also add to set, and we can do that by saying fruit set, and then we can use the add method, and let's say we want to add grape. Okay, and actually we need to print this out, so let's say print fruit set, and we'll run it, and down here you can see that grape has been added to the set. If we want to remove something, we can use the remove method. So we could say fruit set dot remove, and let's remove grape. Okay, so if we go ahead and run this now, you'll see that there's no grape. We removed it. If we want to clear the set entirely, we can do that as well. So we can say fruit set and we want to do dot clear. Now if I try to print fruit set, even though I cleared it, it just gives us basically an empty set. Okay, now you can delete it altogether, which is different from clearing it out. Clearing it out, you still have the fruit set, there's just nothing in it. If you want to delete it with del, and then you try to print it out, it's going to give you an error and say it's not defined. So deleting it is the same as just never defining it. All right, so I think that's going to be it for tuples and sets. So let's move right along to dictionaries. And dictionaries are they're collections which are unordered, they're changeable and indexed. Oh, that's one thing I forgot to show you in I meant to show you this in sets. No, not sets. Yes, sets, because there's no duplicate members. So I wanted to show you what happens if we were to add something that's already there. Sorry about that, guys. So I'm going to go down here. Let's see. I should have did this before all this. Let's say add duplicate. So there's already apples, right? So we'll add apples. And if we run that, you'll see we don't get any kind of error or anything like that. It just doesn't add apples twice. Okay, it's already there. It's not going to add it twice. Okay, so I just wanted to show you that before we moved on. So a dictionary is very, very similar to an object literal in JavaScript. It's similar to a hash in Ruby. You know, every language, they're all very similar and they have similar data structures, but sometimes they're named differently or there's subtle differences. But if you know like JavaScript objects and JSON, they're very similar to that. So let's create a dictionary. So we'll say person. I'm going to open up some curly braces, and then we have key value pairs. Now the keys should have quotes like that. Okay. And then we're going to put this as a string of John. So first name, we'll put a comma, and then last name, which we need quotes. So last name Doe, and let's do age. And age I'm going to make an int, so no quotes. Okay, and if we go ahead and print, and we can print person, let's print the type as well. Okay, and we'll go ahead and run this with Python 3 dictionaries.py. So it gives us the dictionary and it gives us the class of dict. All right, so we can also use a constructor. So to use a constructor, we can say, let's do person person2 equals dict, and in here we can do first name. This is a little different. We'll do first name equals Sarah, last name equals Williams. And if we go down here and we print the type and the value of person2, you'll see that it prints out the dictionary and the class of dict. But I'm going to comment that one out. Now if we want to access a single value or get a value, like let's say we want to get the first name, we can go ahead and print person. Now in JavaScript we would do .name with an object literal. In Python with a dictionary we're going to use brackets and say person name like that. I'm sorry, first name. Okay, so let's go ahead and run that and we get John. Now there's another way to do this, and that's using the get method. So if we say print person dot get, and then we can just pass in as a parameter what we want to get, which let's do the last name. Okay, so if we go ahead and run that, we get Doe. So you can use either way. This is the more common way. We can also add something. So let's say add key value. We'll take person, and let's say we want to add a phone number. So we'll say phone, and we'll set that to a string. Look at, there I go with the semicolon. Okay, and then down here we'll go ahead and print person, run that, and notice that now there's a phone number added to this dictionary. Another thing we can do is we can get all the keys if we want. So let's say get dictionary keys, and we can do that by saying person.keys. Okay, so let's go ahead and run that, and what it does is it gives us this dict keys and then first name, last name, age, and phone. At the same time we can get the items. So let's change this to items, and we'll save that, and it gives us this right here, dict items, and first name John, last name Doe. So that's how we can get items. Now I'm going to show you how we can copy a dictionary. So I'm going to create, let's say person2. I don't have that up here, right? Yeah, I commented that out. So I'm going to say person2 equals the person dictionary with the copy method. Okay, and this is similar to I know I keep bringing up JavaScript, but again, I know a lot of you guys are very familiar with JavaScript. So this is kind of similar to how the spread operator works, where you would use it to get all the values of an object, and then if you wanted to add to it, you could. So what we're going to do is take person2 now, which is a copy of person, and let's add a city value to it. So we'll say city equals Boston. All right, and then we'll go ahead and print person2 and run this, and now right here is where we want to look. This is person2, which is a copy of person1 or person, but also has the city of Boston. Okay, so let's move on, and I'm going to show you how to remove an item. So to do that, we can use del. We'll say del person, and let's remove the age. So we'll pass in age, and then down here we'll go ahead and print person, and let's run it. And this last one here, you can see there's no age. Another way we can do this is with pop. So person.pop, and we can just pass in whatever the field we want to remove. So let's say phone, and now if we run this, you'll notice that the age and the phone is gone. Let's see, we can also clear Okay, just like we can with some of the other data structures, we can do person dot clear. And if I try to print person, what we're going to get is just an empty dictionary. So just this set of empty curly braces. We can also get the length. Let's see, we still have person 2, so let's do print. And just like with the other structures, we can use the len function and then just pass in person 2. And let's see what we get. So that gives us 5. All right, so it gives us 5 because person 2 has 5 key value pairs. Now, just like with JavaScript, a lot of times you'll have an array of objects, so we can also have a list of dictionaries. So let's create people and set that to a list. So we're going to create some square brackets here, and then inside here we'll have a dictionary. And let's just do name. We'll say name, Martha, age 30, and then we'll put a comma and we'll put another one. Let's say name Kevin and age 25. Okay, so now we have a list of dictionaries. I'm going to show you later on how to loop through these and stuff. But for now, let's just go ahead and print this. So we'll print people. And there it is. So it's just an array of dictionaries. Now, if I wanted to get, like, let's say the name of this first person here in this list, I could say people 1, which is going to choose this dictionary, okay, this item, and then the specific field which I want, which is name. So that should give me Martha. So we run that. I'm sorry, it should be Kevin because Kevin is in the 1 position. Martha is 0. All right, so I think that's going to do it for dictionaries. Let's clear this up and let's move on to functions. So we're going to open up functions.py. Now, a function in Python, it basically does the same thing as it does in most languages. It's a block of code which runs when it's called. Now, there's a big difference in the way we format functions than most C syntax languages. Okay, we don't use curly brackets. We use a colon and then we use indentation. Okay, and that can be with tabs or spaces. So let's go ahead and create a function. So I'm just going to create a simple function called say hello that just takes in a name parameter and then just prints that out. So to define a function, we actually use the def keyword. Okay, so we want to define say hello. And instead of doing this like we do in many languages, we put a colon and then we just want to indent one over from here. Okay, and in VS Code and any good text editor or IDE, it usually does this for you. So let's go ahead and just print, and I'm actually going to take in a parameter here. So let's say name, and let's just do a print. We'll use an F string here. So we'll say print hello name. Okay. Now this by itself isn't going to do anything. We just define the function. We actually have to call it. So we'll say hello, and then we have to pass in a name. We'll just say John Doe. All right, so go ahead and save. Now I do have the prettier extension installed in VS Code, so it does kind of format it on save a little bit. So that if you see me save and things change a little bit, that's why. So let's run this. We're going to say Python 3 functions.py, and we get hello John Doe. All right, now we can also do default arguments or parameters, because if I were to do just say hello without anything in it, we get an error. It says missing one required positional argument. But what we can do, if we wanted to set a default, we could say, like, let's say equals Sam, Sam. So name equals Sam, and if we run say hello now with no argument, you'll see we'll get hello Sam. Okay, so you can do that. All right, so usually you're going to deal with return values. Okay, when you run a function, usually it's you get something from it. You almost never are going to print something out like this, unless its point is to be a logger or something like that. So let's create a function called get sum, and get sum will take in num1, num2. I'm sure you can guess what this is going to do. It's going to let's see, we could just return, let's actually create a variable within the function scope called total. We'll set that equal to num1 plus num2, and then we're going to return total. Okay, now when we set variables inside functions, it's in this scope. Okay, so outside of it is going to be the global scope. This is the function scope. So this will return the total. So we can go down here. If I just do get sum and pass in, let's say 3 and 4, and I try running this, we're not going to get any output because we didn't print. Print is what causes the output to the console. So I could wrap this in print and run it, and then we get 7. A lot of times, though, you'll use the return value in some way, and you'll assign that to a variable. So let's say num equals get sum of 3 and 4, and then we could print num. We'll run that, we get 7. So num is equal to 7 because it's equal to the return value of that function. All right, so I want to move on here to what's called a lambda function. So a lambda function is a small anonymous function. It can take any number of arguments, but can only have one expression. And again, I'm comparing this to JavaScript, very similar to arrow functions. Okay, so if you're familiar with ES6, if you use React or anything like that, I'm sure you've used arrow functions before. This is pretty similar. All right, so let's take the get sum example up here, and let's turn this into a lambda. So we could just simply do get sum equals, so we're setting a variable just like in JavaScript. We would do like const get sum. I could even never mind. So get sum equals, and then we use the lambda keyword. Okay, and then we want to put in our parameters. So we have num1 and we have num2. All right, and then we're going to put a colon here, which is kind of like an arrow with an arrow function, and then our expression, which is going to, or the body of the function, which is going to be num1 plus num2. Okay, and it's going to implicitly return whatever this expression equals, and it's going to put it into this variable. So if I go ahead and I say print get sum, and let's pass in 10 and 3. So if I run this, we should get 13. Wait a minute. Oh, you know what? I think my prettier extension just turned this into it added def and added the return. I shouldn't need those though. I shouldn't even need these parentheses. Yeah, it turned it into a regular function. Let me try that again. Got rid of the lambda and everything. See, sometimes this prettier extension doesn't do what I want. Yeah, see, I save it and it turns into that. Huh. You know what? Let me disable that real quick. That's not right. So I'm going to go to settings, format on save. Let's set that to false. All right, so now it's not, I'm saving it and it's not redoing it for me. So let me try this again, and we get 13. All right, so that's a lambda. So we're going to move on now to conditionals. So I'm going to clear this up, and let's open up, we'll save it. Let's open up conditionals.py, which is right here. And we're going to look at if statements, if else statements, and these work pretty much like any other language. You test to see if something's true or false, and you do something based on that condition. So I'm just going to create a couple variables up here. Let's say x equals 10, y equals 5. And when we do an if statement, we can use comparison operators like equals to, not equals to, greater than, less than, greater than or equals, less than or equals. So let's do an if statement here. Now we don't have to use parentheses like that. Like in a lot of languages, you'll use this syntax. We're just going to say if x is greater than y, and then we want to put a colon and then just indent the next line. And I'm just going to do a print. We'll use an f string, and I'm just going to say x is greater than y. And obviously you can do whatever you want in here. I'm just going to print this out though. Okay, so let's save this and let's run it. So Python 3 conditionals.py, and we get 10 is greater than 5. Now, if I were to change y to 50 and run it, we're not going to get anything because this isn't running, because this is not true. Now, you can also have else. Okay, so if we wanted something else to happen if this isn't true, then we could do that. Let me just put a comment here. So this is a simple if. And then we'll just do, let's say, if else. So I'll go ahead and just copy this. And then let's put an else. So we do else colon and then just indent the next line. And I'm going to copy that print and just reverse it. We'll say y is greater than x. Okay, so we'll go ahead and run this. And we get 50 is greater than 10. Okay, it's running the else because this is not true. So let's see, let's actually copy this if else, because now I want to show you how to use an elif or an else if. It's actually ELIF. So ELIF. So let's say not only do we want to test to see if it's greater than or less than, but also if it's equal to. So in the middle here, I'm going to put ELIF colon, and then we'll go ahead and print something. So we'll print x is equal to y. Okay, so if I run this right now, wait a minute, what did I do wrong here? Invalid syntax. Oh, I didn't put a condition. So this elif here, obviously this needs a condition. We're going to say if x is equal to y. All right, so if we run this now, we're going to get 50 is greater than 10. But if we change this to be equal, like let's change y to 10 as well, and we run it, now we get 10 is equal to 10. Okay, this right here, this condition is true, so it's running this. Now we can also do nested if statements, which is an if within an if. So for instance, if I wanted to do if x is greater than 2, and then do another if statement here and say if x is, let's say, less than or equal to 10, then let's do a print. We'll say x is greater than 2 and less than or equal to 10. So we can do that, and right now it's equal to 10, so that should run. Wait a minute. Oh, I forgot my indent. Okay, so now it runs. Now this isn't a great way to do this. If you wanted to do this exact condition, what I would suggest doing is a logical operator and using AND, okay? Because what you're saying here is both of these need to be true, right? So what we could do is we could instead say if x is greater than 2 and x is less than or equal to 10. Okay, so it's a cleaner way of doing it, and then we would run that. Okay, so let's comment this out and run that, and we get the same thing. And you can also do or and not. So if I were to copy this and do or, the difference here is with and, both of these have to be true for this to run. With or, just one of these has to be true, one or the other. So this would be or. All right, and then we also have not. So for not, let's just do something really easy. I'll say if not, and we can pass in here a condition like x equals y, then, oops, actually we'll just type this out. So print x all right, and that actually they are equal right now, so I'll change that to, let's say, 20, and now that should run. So you'll see right here 10 is not equal to 20. So in fact all three of these are running because they all evaluate to true. All right, actually no they don't. Hold on. Y. Oh yeah, they do because we didn't even test y. All right, so I'm going to comment this stuff out. And let's move on to membership operators. So basically what this is used for a lot of times is to test to see if something is in like a list. So if we do numbers and we set this to a list, and let's say we want to test to see, we don't need that. If we want to test to see if 3 is in the list, I'll actually change the x value up here to 3. So let's say if x in the name of the list, which is numbers, then we could do something. And we could even do this. We could say print, and we could do x in numbers just like we did in the if. And what this will do is give us a true or false. Okay. So if this is true, then this is going to give us true. So if we were to run this, you can see we get true. At the same time, we have not in. Okay, so this is an in, and we also have not in. So we can say if x not in numbers, then let's print x not in numbers. Right now, that's not going to run because 3 is in the numbers, but if I were to change it to, let's say, 13 and run it, we get true, which is corresponding to this right here. Okay. We also have identity operators of is and is not. So for instance, and I don't use this too much, but we could, just to show you it's possible, we could do like if x is y, and then we could do the same thing we did above by printing the conditional, or we'll get a Boolean from this condition. Print x, is y. So let's actually comment this out. And if I run this, we get nothing because x is not y. But if we change it to 20 and we run it, then it should give us true. Okay, it gives us true because x is y. And then at the same time, you could do is not. So we could say x is not y, and then we'll print true if x is not y. So we'll change it to something else, and we should get true again from that statement. And that's that. All right, so that was a little longer than I wanted to spend on conditionals, but yeah, so it's pretty simple, at least basic if else and stuff like that. So now we're going to move on to loops. Okay, loops are an important part of any language. A loop is used for iterating over a sequence that is either a list, a tuple, a dictionary, a set, or a string, or a custom condition. So let's do a simple for loop that loops over a dictionary. So we're going to say people equals, I'm sorry, not a dictionary, a list. So let's say John Paul, Sarah, and Susan. All right, so I just want to do a simple for loop. So I could say for person. It's actually a for in. If you're familiar with ES6, we have for ins in JavaScript ES6. So we can say for person in people. And let's go ahead and print. And let's just put an F string in here. We'll say current person. And then we'll put in the variable of person, which represents whatever person in that current iteration. So let's go ahead and run Python 3 loops.py, and we get current person, John. It goes through again, Paul, Sarah, Susan. Now, we can also break out of a loop if we want. So let's look at break. So I'm actually going to copy this, but I want to say here, I'm going to use an if statement. I'm going to say if person is equal to, let's say, Sarah, then I want to break. Otherwise, I want to print this current person. So let's see what happens here if I comment this out. Notice that we just get John and Paul. So what happened is we broke out of the loop. We basically stopped it if the person was Sarah. Now we also have a continue. So let's see what happens if we do that. So I'm going to copy that. And instead of saying break, we're still going to test to see if it's Sarah, but instead of break, let's do a continue. And let's comment this out. So now we get John, Paul, and Susan. So it didn't just stop the loop when it got to Sarah like it did with the break. It basically just skipped Sarah and kept going and then called Susan. Okay, so that's the difference between break and continue. So we also have something called range. Okay, so let me give you an example of that. All right, so I'm going to say for I in range. Now we could put anything we want in here, basically any range, any numbers. First I'm going to show you how to use it with the list we just created, the people list. So we can take the length of people. Okay, so for I in the range of the length of the people list, and then let's just print, we'll say people I. Okay, so this is similar to just a standard for loop. We're going to go ahead and run this, and it's just going to print out all the people's name. I could have did an F string, current person or whatever, and instead of just person, I'd have to use people and then I. And we can do custom ranges as well. So if I wanted to do for, oops, don't want that, for I in range, and then we could put, let's say 0 to 11, and then let's just print, we'll print an F string, we'll say number colon, and then we'll put in I. Okay, we'll run that, and it's going to go, as you can see, whoops, it's going to go from 0 to 10. All right, so starts at 0, goes to 10 because we said 0. It's not actually going to go to 11. It's not going to show the 11. It's going to go to the number before that. So we can also do while loops. So while loops execute a set of statements as long as a condition is true. So we could set a variable outside of the loop like count, set it to 0. We could say while count is, let's say, less than or equal to 10, then let's go ahead and print, and we'll say count, and then we just need to increment count by 1, so we can actually just say count. we could do equals count plus 1, or the shorthand would be just plus equals 1, like that. So let's try it out. Let's clear this and run it, and we get count up to 10. Okay, because we said less than or equals to 10. If we just did less than, it would bring us to 9. All right, so that's loops. Next thing we're going to look at is modules. Okay, so a module is basically a file containing a set of functions to include in your application. You have core Python modules. You also have modules that you can install with the pip package manager, and Django is one of those, as well as custom modules. Okay, so you can create your own modules. And I'm going to give you an example of all three of these. So first thing I'm going to do is I'm going to show you how to import a core Python module where you don't have to install it, you don't have to do anything except import it. An example of that would be the date time module. So to import a module, we use the import keyword, and let's say import date time. And I want to use this, so I'm going to go down here, and let's say we'll create a variable called today. And let's set that to date time dot date dot today. Okay, and if you look at the documentation, you'll see all the different methods and properties and stuff that are available. So let's print today, and let's see what we get. So we're going to say python3 modules dot py. And that's what we get. Okay, so today is 11/28/2018. Now notice that I did datetime.date.today. So this date object is actually in date time. And if I wanted to, I could actually import just date from date time. Okay, instead of importing the whole thing. The way I would do that is by saying import, I'd say from date time. I want to import just date. Okay, now if I do that, I can then do today equals date dot today. Okay, so I don't have to use date time because I brought, I imported in date from date time. So let's save that and see. We should get the same thing. Excuse me. Let's look at another one. Let's bring in time. So we'll say import time. And let's see, let's go down here. And let's create a variable called timestamp and set that to time. And then we'd actually have to do dot time dot timestamp for that to work. Wait, is that right? No, I'm sorry. It's just time.time, like that. And then let's go down here, timestamp. And what it does, what that timestamp, our time method does, is prints out the current timestamp. So let's run this again, and it's going to change each time. Okay, because the timestamp is obviously keeps changing. Now, this looks kind of funny, so what we could do is just import time, just the time method from the time module. So just like we did with the date time, we could say from time import time, and then we could simply go like that, and that should do the same thing. All right. So those are examples of just core modules that are available by default with Python. Now, Python has a package manager called pip. And again, comparing it to JavaScript, where you have Node.js, you have your npm package manager. You have Ruby gems. A lot of different languages have different package managers for installing external modules or programs. Excuse me. So to install something with pip, you want to do pip install, but since my Python 3 is available in my Python 3 command, then I want to use pip 3. Okay, unless you set up what's called a virtual environment, which we're not going to get into in this crash course. We do that in the Django Udemy course, but let's go ahead and install something using pip, or pip3 in my case. So there's a very, very small module called camel case, which just takes a piece of text and makes it camel case, meaning capitalizes each word or whatever. So let's do pip3 install camel case. Now, what this did, actually it's already installed, so that's why mine went so fast. But when you run it like this, it's installing it globally on your system. Now, like I said, you can install something, you can create something called a virtual environment, where when you install something with pip, it gets just installed in that environment. You can also use something called pipenv or pipenv, which does the same thing. You have these encapsulated environments. In my case, it just got installed globally, kind of like doing npm install with a dash G or dash global. Now, if I want to see what's installed, I can say pip3 freeze. Okay, so this is going to show me all of the modules that I have installed, and since I'm in a global scope, this is what I have installed globally, and you can see camel cases right here. All right, but if I were in a virtual environment, it would just show me what is in that environment. So now that we have that installed, we can import it just like we did with these other ones. So I'm actually going to put a comment here. So these are core modules. And this is, we'll say, pip module. So we can import camel case. It'll actually pop up here. So import camel case, and let's go down here. And what we need to do is basically instantiate a camel case object. So we'll say C equals, actually, you know what? We'll bring in camel case, bring in the method. So I'll say from camel case, we're going to import a method which is called camel case, and we want to make these uppercase. All right, so doing that, we can just say C equals camel case. Now this object now has methods on it. One of them is hump. Okay, so we can say print c.hump. I know that sounds a little weird. And let's pass in like hello there world, all lowercase. And let's run that. And you can see that what it did is it made every first character of each word uppercase. Okay, so it's a very, very simple module, but it's just an example of how to install something with pip and how to import it and use it. So the last thing I want to do here is create a custom module and use that. So we have this validator.py file, which is already created, already filled out. Basically what this does is it validates an email. Okay, and we imported the RE, the regular expression module, which is a core module. We created a function called validate email, takes in an email, and then checks the length of it, and then it uses that regular expression module, which has a match method, and passes in a regular expression to validate an email. Okay, and it returns a Boolean, it returns a true or false based on if that is an actual email or not. So let's say we want to use this as a module. So I'm going to go back to modules.py, and we're going to bring this in. So let's say import custom module. So we'll say import validator, and actually, you know what? I mean, we could do this, and we could use validator.validate email, but we could also do from validator import validate email. It'll actually show us that. Okay, Okay, now we can use this validate email function, and we could have as many functions as we want in the validator. If you wanted to have, like, I don't know, validate username or something, and even have it connect to a database and see if a username is already taken or something like that. So down here, let's have an email. We'll set it to test@test.com. Actually, it should be a string. So it's a valid email. And we're going to just do if validate email, pass in that email, and then we'll do a print email is valid. Okay, and then we'll do else print email is bad. All right, so let's get rid of this print here. Get rid of this one. Okay, let's run it. So we get email is valid. If I change this to be, like, let's say test, and we'll put in like a number sign here, we get email is bad. So it's using this validate email function. It's bringing that in from our validator module, which is a custom module that we created. Okay, so that's how you can use custom modules. All right, so now we're going to move on to classes. Okay, with Python, you can do all types of different programming types. You know, you can do procedural. You can also do object-oriented programming, and a class is used to create objects. Okay, an object has properties and methods. Methods are basically just functions that are associated with it. Almost everything in Python is an object, and you can see when we have a string, we can call methods on it. A string is an object, and almost everything is an object. So let's go ahead and create a class. I'm going to try to do this quick because we're really running out of time here. So let's create a class called user. And if you've created classes in PHP or Java, C#, I mean, it's pretty similar. So we can have a constructor. So a constructor is basically a function that runs when you instantiate an object from a class. And we want to define this as _init, _. And this is going to take in self. And it can take in other properties as well. Like, let's say this user, we want to have a name, and then inside here we can assign self.name equal to name. Now, in a lot of languages, and when you use a class, you'll use this. Okay, so in a standard Python class, you're going to use this self. Okay, so just think of that as this if you're coming from like ES6 or PHP or something. So to create an object, let's say we'll initialize user object. We can do, like, let's say Brad, excuse me, I'm losing my voice. Brad equals user. Okay, so we're saying Brad is going to be a user object, and we can pass in a name like that. So just doing that will create the object. So, I mean, if I save that and I run python 3 classes.py, we're not going to see anything, but it did instantiate the object. In fact, I can do a print. Let's do print type Brad. Oops. And you'll see that it gives us, basically telling us that this is a user object. Now, I'm going to add a couple other properties here. So let's do name, email, and age, and then we just need to go in here and say self.email equals the email that's passed in, self.age equals the age that's passed in, and then we'll go down here, we'll add that in. So brad@gmail, not my real email address, by the way. And then let's do 37. Okay, so we're just adding extra properties. Now let's create a method that is associated with this. Actually, first, before I do that, I want to show you that we can actually access the properties. So let's actually print, Brad.name. Okay, if we run that, we get the name. We can access any property we want, Brad.age. All right, now I want to create a method. So to create a method, it's just like, any other function. We're going to use def. Let's call this greeting. Now these methods that we create within the class are going to take in self, and we want to just return, let's return an f string, and we'll say my name is. Now when we want to access any of these properties from any method within the class, we need to use that self keyword. Okay, so let's say self.name, and I am self.age. And then down here, if we want to run that method, we can simply take the Brad object and call greeting. Make sure you put parentheses because this is it's a method, it's not a property. And if we run this, what did I do? I forgot my colon. So if we run that, we get my name is Brad Traversy and I'm 37. Okay, if we wanted to do another method, like let's say has birthday, and what I want this to do is just add an extra year to my age. So I'll say self.age, and we'll just do plus equals 1. So we'll add a number. Now if I go before we run the greeting, and actually we don't need to print, we just need to take the Brad object and call has birthday. Once we do that, it's going to add 1 to the age, and then we'll do the greeting. So we start off with 37, have a birthday, and then when we print the greeting, it should be 38. And there we go, because I am 38. Okay, so that's the basics of creating a class with methods and instantiating it and calling those methods. You can also extend classes. So let's say, we have a user class. Let's say we wanted to have a customer class and extend that user class. Okay, so we'll go down here, and we want to just create a class called customer. And a lot of times in other languages, like I'm sure a lot of you guys work with ES6 and JavaScript, you would do like extends user. In Python, we want to actually pass it in as a parameter like that. Okay, and then let's basically copy this constructor. So we'll put that here. And I want a customer to be able to have all of these fields, but also a balance. And I want that balance to initially be set to 0. So I'm going to say self.balance, and let's set that to 0 by default. Okay, and then this customer class is going to have a method called setBalance. So let's say def set underscore balance, and that's going to take in self, and it's also going to take in a balance. All right, and then what we want to do is take self.balance, and we want to set that to the balance that's passed in. Okay, so now let's go down here, and let's initialize a customer. So let's say Janet, and we'll set Janet to customer. And customer takes in the same things as a user because it extended it. So we'll say Janet Johnson, Janet at yahoo.com. We'll say 25. All right, so we have Janet who is a customer, so we should be able to set a balance. So let's say Janet.set balance, and we'll set it to, let's say, 500. All right, now I also want to have a greeting for the customer, but I want the greeting to also have a balance in it. So I want to overwrite this greeting. So what I'm going to do is copy this and paste that in, and we just want to add right here to the end of this string. We'll say my name is name, I am age, and my balance is self.balance. All right. Actually, first of all, I want to show you that we can still access parent class methods. So if we don't even do, where am I? If we don't even do that yet, let's do Janet.balance. I'm sorry, not balance, greeting. Sorry guys, this is a long ass video. So if I run that, hold on. Wait a minute. Janet. Oh, I didn't print it. You know, I'm not even going to bother editing that out, guys. I don't care. Okay, so you'll see that Janet, even though as a customer, can still call greeting, even if it's not defined in the customer class, which is right here, because customer extends user. Okay, but if we want to overwrite that and have it do something else, like have the balance in it, we can do that. So now if I run it, we get my name is Janet Johnson, I'm 25, and my balance is 500. All right, so yeah, that's pretty much it, guys. So you create your class, you can add properties, methods, and you can call those properties and methods after you instantiate whatever that object is. Okay, so let's move on to dealing with files. Okay, so files.py. So Python has functions for creating, reading, updating, and deleting files. So I just want, I mean, there's a lot you can do, but I just want to basically show you how to create a file, open it, write to it, stuff like that. So to open a file, we can create a variable. Let's call it my file. We want to set it to open and then give it a name, and this open will actually create it. So I'm going to call it myfile.txt. It's going to be a text file, and we want to write to it, so we want the mode, which is going to be W, okay, for writing. So let's save this. We'll go down here and we'll run this. So Python 3 files.py, and over here you'll notice that it created myfile.txt. Just this one line created a file on my system. So we can get info on this file. So we can print, let's do print name. Yeah, we'll just do this. So print name myfile.name. Okay, so my file is basically an object that has properties on it that we can access. So we can do name, we can see if it's closed or not. So let's say is closed, and this has a property called closed. And we also have a property called mode. Change that to opening mode. Oops. All right, so let's run this. So it gives us the name, is closed is false, opening mode is W. And what I mean by closed is not the actual file closed in our system, but if we closed it within within our script here. So let's write to the file. Okay, so we'll say write to file. So we can take my file and we can call .write, and let's put in the string I love Python. All right, and then let's also do my file dot write, because we can keep writing to it. We can append to it, let's say, and JavaScript. Okay, and then we want to close it, so we're going to say my file dot close. So if we ran this is closed on down here, it would be true. So let's save that and run it. And let's go to the text file, and there we go. I love Python and JavaScript. Okay, so let's say we want to, after this has already been closed, let's say we still want to append to it. We still want to add to it. So what we can do is we can then open it again. So just like we did up here, we're going to say equals open my file text, only this time we're going to use a. We want to append to it. Otherwise, we're going to overwrite it. We don't want to do that. So go ahead and paste this in, and let's put I also like PHP. And then we'll go ahead and close it. Okay, so we'll run that again. Let's take a look. I love Python and JavaScript. I also like PHP. So it's as easy as that. And if we want to read from a file, we want to open it again. This time we want to use R plus as our mode, and let's create a variable called text, set it to my file dot read. Let's read 100 characters and let's print it. Okay, so we'll go ahead and run that, and there we go. I love Python and JavaScript. I also like PHP. So that's starting to work with files. Obviously, there's a lot more you can do. But we're going to move on now to working with JSON. Okay, so JSON is commonly used with data APIs. Here's how we can parse JSON into a Python dictionary. So a lot of times you might be dealing with third-party APIs where you're dealing with data that comes in as JSON. And you're going to want to be able to parse JSON into a Python dictionary so you can work with it. You'll also probably want to parse a dictionary as JSON. So there is a module called JSON that we can use. So we want to import JSON. And I'm going to just create some sample JSON. Like we can pretend we're getting this from some outside API or something. So let's say user JSON equals, and it's going to be a string of JSON which has double quotes around the key and value. So let's say first name John, last name Doe, and age, and that's a number, so we can do 30. All right, now we want to be able to parse this to a dictionary. Okay, just like we have JSON.stringify and JSON.parse in JavaScript, we have methods like that in Python. So let's say user equals JSON, and we want to do JSON.loads and then user JSON. Okay, so then we'll go ahead and print user. And then down here we want to run Python, and the name of this file is py_json.py. And the reason I unexpected indent. Oh. Okay, so it gives us the dictionary of the user. Now, the reason I call this py_json and not json.py is if I use json.py, we get a conflict because that's the name of the module, in case you're wondering that. All right, so let's say we wanted to just get just the first name. We could do print. Let's do print. Actually, we'll move this down here. Let's do print user first name. And since it's a dictionary, we should be able to do that. So let's run that, and you can see we get John. All right, now I'm going to show you how to do the opposite and take a dictionary and turn it into JSON format. So let's say we have car, which is going to be a dictionary. So make, we'll say Ford, and let's say model Mustang, and let's say year 1970. So that's a Python dictionary, right? Now we can say car JSON, we'll create a variable, and then we can use that JSON module and we can say dot dumps and pass in car. Okay, so this will do the opposite. So if I go ahead and print car JSON, let's comment out these prints and let's run that, and now you'll see that it's in JSON format. We have the double quotes. All right, guys, so that's going to be it for this crash course. I hope you enjoyed it. I know it was very, very long, but I wanted to cover a wide range of just core concepts that you're going to need to know to do anything in Python. And I know that it's kind of difficult to see how a lot of this stuff is useful. Like, how can you actually create something from it? But it's all needed. If you look at any Python script, you're going to see dictionaries, functions, conditionals, lists. You're going to see all this stuff. So what I would suggest next is to move on to tutorials or books or courses that are going to actually show you how to put it all together and build a project with it. But again, these crash courses, these are always going to be the very first step to take. So that's it, guys. Please leave a like if you like the video. Also, if you want to check out the Django course that this is based off of, I'll leave a link in the description with a promo code for just $9.99. All right, that's it. Thanks, guys, and I'll see you next time.